All right, let's talk about AI. Have you ever wondered if there's a smarter way for it to learn? Today, we're diving into a really cool new idea from researchers at DeepSeek AI in Peking University. They've come up with an architecture that could totally change how large language models work, making them not just more powerful, but way more efficient. Let's get into it. So, to kick things off, let's start with a bit of a puzzle. Why is it that our most advanced, most powerful AIs have to relearn really simple facts from scratch every single time we ask them something? It seems kind of crazy, right? Well, it is, and that's the core problem we're going to unpack today. To really get to the bottom of this, we first need to understand that these language models are constantly trying to do two very different jobs at the same time. On one hand, you've got what we call compositional reasoning. Think of this as the heavy lifting, the deep thinking, problem-solving, creative writing part. It's dynamic. On the other hand, you have simple knowledge retrieval. This is just pulling up static facts like, who was Diana, Princess of Wales, or what's the capital of France? Right now, the AI uses the exact same powerful, expensive tools for both of these jobs. Okay, so how do today's big models actually handle this balancing act? Well, as we're about to see, the way they do it comes at a surprisingly high cost. The current standard for these huge AI models is something called mixture of experts, or MOE for short. The best way to think about it is like having a massive team of specialists. For any problem you give it, a little router inside the AI activates just a few of these experts to tackle it. It's actually a really clever way to have a giant model without lighting up the whole thing for every single thought. But here's the catch. Here's the big inefficiency. When the model just needs a simple fact, like remembering who Diana, Princess of Wales was, it still calls on this elite team of specialists. It wastes their brain power, their computational depth, to piece together this really basic information from scratch. It's like calling it a team of neurosurgeons to put on a Band-Aid every single time. The researchers themselves put it perfectly in the paper. They said this process essentially amounts to an expensive runtime reconstruction of a static lookup table. In other words, the model is wastefully rebuilding a simple dictionary every single time it needs to look up a word. There has to be a better way, right? And of course, there is. This brings us to the core breakthrough from these researchers. What if, instead of just having computation, you gave the AI a dedicated memory? So, what is the solution? Well, instead of forcing that team of specialists to do all the work, they gave the AI a reference book. This new module, which they call Engram, works right alongside the specialists. So the specialists handle the tough, dynamic reasoning, and the Engram, the reference book, handles the instant lookups for static facts. So what exactly is an Engram? Well, at its heart, it's a super efficient memory system. It's actually a modern twist on a classic idea called engrams, which are just sequences of words. The engram lets the model just look up information tied to these word sequences instantly, instead of having to recalculate it from the ground up. And here's roughly how it works. First, it uses a really fast hashing system to find bits of memory that might be relevant, kind of like quickly flipping to the right page in that reference book. Then, and this is the really smart part, it uses something called context-aware fusion to figure out if that memory actually makes sense in the current sentence. And finally, it feeds that useful info back to the main model. Pretty cool. Okay, so the theory makes sense, right? A team of specialists plus a reference book, that should be better. But does it actually work in the real world? Well, the researchers put it to the test. And frankly, the results were pretty surprising. So they started experimenting with how to split the AI's resources between the specialists, the computation, and the reference book, the memory. And what they found wasn't a straight line. They found this very clear U-shaped curve. If you focus too much on just computation, performance drops. If you focus too much on just memory, performance also drops. The sweet spot was a hybrid, right there in the middle. And get this, the best balance wasn't even 50-50. They found the peak performance came from dedicating about 20% of the model's capacity to this new memory module. It just goes to show you, even a little bit of dedicated memory can make a massive difference. So with that 20% rule in mind, they went and built a huge 27 billion parameter model to test it out. And when they compared it to a traditional model of the exact same size, the new hybrid model, well, it won. It showed major gains across every single category: knowledge, reasoning, coding, you name it. But here's the part that really made me sit up. This is the big twist in the story. The biggest improvements weren't just in simple knowledge lookups, which is what you'd totally expect, right? You add a memory, it gets better at remembering stuff. Nope. The gains were actually even bigger in the really complex areas. The single biggest jump was in general reasoning, with coding and math right behind. So, why? Why would adding a simple reference book make the AI a better problem solver? It's because by offloading all those tedious, simple lookups to the Engram reference book, the model's powerful specialists were freed up. They didn't have to waste time and energy figuring out basic facts anymore. All of that freed up capacity could then be dedicated to higher level thinking, which basically makes the whole system smarter and functionally deeper. So, a smarter, more efficient AI. That's obviously a huge deal. But this isn't just some academic paper. This has some massive, real-world implications for how we're all going to be using AI. First off, it's a game changer for understanding really long documents. Think about summarizing an entire book or analyzing a dense legal contract. Performance just skyrocketed. On one key test, the accuracy jumped from about 84% to a whopping 97%. When the memory handles the small details, the AI's main brain can focus on the big picture. And looking forward, the potential here is just enormous. We're talking about 3 huge things. 1, this could accelerate edge AI, letting powerful models run right on your phone. 2, energy efficiency. This could cut the energy use of these massive models by up to 20%. And 3, this kind of smarter, more efficient design is a really important step on the road to more capable general AI. Which brings us to a final, pretty provocative thought. For years, the AI race has been all about raw power, just building bigger and bigger models. But this research points to a totally different path. It makes you wonder, will the next great leap in AI come not from just adding more computational muscle, but from building a smarter architecture with a better memory? It's a fascinating question to chew on. Thanks for tuning in.